Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3 for October-November 2023. And this is paper 3 part 2 for questions 7 to 11. Question 7 is coming from implicit differentiation. The equation of the curve is given by this. Show that dy dx is this one here. So we are going to differentiate everything with respect to x. So we have here the x cubed, then plus we differentiate this one with respect to x, then also this one here with respect to x, everything, okay, to get the dy dx. So we also put 3y here, and also this one with respect to x. This one is a constant, automatically would give us a 0. Now when I'm differentiating, let's say with this y squared with respect to x, I will first differentiate this y squared with respect to y, okay? Then after I multiply by dy dx, okay? This will go, then I remain with my dy, okay? The derivative of y squared with respect to x. Why are we doing that? Because y is a variable. So since it is a variable, you have to differentiate it with respect to it. You see that? So here, of course, we get 3x squared. It is even the same thing here. You have 3x squared, then times dx. You see? But this one, we don't write it, so it just goes. Because the function was already in terms of x. Then plus, this will be 2y, then dy dx. Then plus, this will be 6x. Then here, we shall get a 3, then times dy dx. And then this way, we are having 0. So the two parts that I've gotten, dy dx, we factorize out that dy dx. So we have 2y plus 3, then dy dx. Then this one will be equal to this one here and this one. Let them go this other side, okay? So if they go there as negatives. So we shall have negative. In fact, I can just factorize it out. And then I say that is negative 3x squared plus the 6 of x, okay? Now, we divide all through by this, so that simply implies that our dy dx is going to be equal to negative 3x squared plus 6x, then divide by 2y plus 3. And this is what they have told us to show. So for them, they write their negative here, but it affects the whole thing. So when I put this one in bracket like this and I put a negative, it is the same thing, okay? So that is that. Then part B, hence find the coordinates of the points on the curve at which the tangent is parallel to x-axis. I'm going to draw a simple sketch here. Suppose I have my axis here, just like this. And then maybe this is the line. This is x-axis, and this is a line which is parallel to x-axis, okay? So I have y here. This line parallel to x-axis is having the equation y is equal to something. Maybe y is equal to b. You see that? Now, it has an x coordinate here. Let's say this is x1. Then the y coordinate is there. Let's say it is b, because I've put here b, okay? Then there is another x coordinate here, which is x2, okay? This is x1. So we are going to have x2 here and b. Now, when I'm finding the gradient here is going to be equal to the change in y over the change in x. You can see that the change in y is b minus b, which is actually going to be 0. But the change in x is there because we have x2 that is different from x1, okay? So that means the gradient of a line that is parallel to x-axis is always equal to what? 0. Or you can get the numerator and you equate it to 0. Then for the one where the line is parallel to y-axis, x coordinates are not changing. That means when we subtract, there will be a change in y, but the change in x would be 0. So for that case, for a line that is parallel to y-axis, you get the denominator of your dy dx, you equate it to 0, and then you solve accordingly. So we shall get our dy dx, which is given as negative of 3x squared plus 6x, then we divide by 2y plus 3, then this one is going to be equal to 0. Of course, when you cross multiply, this one will disappear. Then I will have I will have 3x squared, then plus 6x, which is equal to 0. I also divided all through by the negative, so it disappears. You see? Now 3x here is common. Then we can have x plus 2, which is equal to 0. Meaning when I equate this one to 0, my x is going to be equal to 0. And also when I equate this one to 0, my x is going to be negative 2. They said, hence find the coordinates of the points. So that means it is more than 1 point. Now, for x equal to 0, what is the y coordinate? So we go back to our equation, which was given. The equation is this one here, x cubed, then plus y squared plus 3x squared plus 3y. So we substitute in here. So we have the equation is x cubed. Okay, let me write it here. X cubed plus y squared, then plus 3x squared plus 3y, which is equal to 4. So if x is 0, then I'm remaining with y squared, then plus 3y. I can bring this 4 this way, and then it becomes a minus 4, which is equal to 0. This one can easily be factorized, okay? And I can have y plus 4, and then y minus 1. Because when you get this 4 and this negative 1, you multiply them, you get this negative 4 here. And then when you add these two, they will give you the positive 3 here. So that is what I have there, which is equal to 0. So meaning y can be equal to negative 4 when I equate this one to 0. And then y here is going to be equal to 1 when I equate this one to 0. So what does this mean? We are having the coordinates. If x is 0, then y is negative 4. There is also x being 0, and then y is 1. So here I have these 2 points. Okay. Then we also have another point here. For x is equal to negative 2, what do we get? Okay, so for x which is equal to negative 2, then we are going to substitute here. So we shall have negative 2 x cubed, then plus y here, y is squared, then plus 3, then times negative 2 squared, and then plus 3y, which is equal to 4. So all the power of a negative is always a negative, okay? So we are going to have negative 8 here, then plus y squared, then minus, this will be 12. It will be a plus, because negative 2 squared is a 4. So we shall have 4 times 3, which is 12, and then plus 3y, then it's equal to 4. I can actually bring the 4 this side, and it becomes a minus, so it's equal to that. So the quadratic here that comes out is y squared plus 3y. We have minus 4 plus 12, you get a positive 8. Then minus 8, that is a 0. So meaning we have only these two, which is equal to 0. Now y is common. Then we can have y plus 3, which is equal to 0. So when I equate this one to 0, that means y is equal to 0. And when I equate this one to 0, then y will be equal to negative 3. So meaning from here, when x is equal to negative 2, we are having coordinates negative 2, 0. And then the other one is negative 3. I mean, the x coordinate is a negative 2, so negative 2, then negative 3. So we also have these two coordinates here. So the coordinates that are needed are 4 of them. So that is that. Question 8 is coming from differential equations. The variables x and y satisfy the differential equation. This one here, it is given that y is equal to 0 when x is equal to 2. Solve the differential equation, obtaining an expression for y in terms of x. The first thing we do, we separate variables, and the operation that we do, it is either multiplication or division. Okay, so we can cross multiply here. When we cross multiply, we can bring this cos squared down here, and then you take the dx here. Then after you divide all through by this. Okay, so separating variables. Separating variables. I can begin by saying e power 4x, then dy is equal to cos squared 3y, then dx. Then you can divide all through by this. Then after you divide through by this. So that means we are going to have dy out of the cos squared 3 of y, which is equal to dx out of e to the power of 4x. And then we integrate, separating variables and integrating. So we are going to have integrate this way with respect to y and also this way with respect to x. So this one here is actually 1 over cos squared is sec squared. So this will be sec squared 3y dy. And then this one, I can take it up using the rules of indices, the power becomes a negative, okay? And when we integrate e to the power of a function with respect to x, this one is going to be get the power here, you differentiate it, then after you divide through. So you divide by this exponential function, by its derivative. Now, for differentiation, we multiply. For integration, we divide. Then we also have when we differentiate, okay? When you differentiate tan of, let's say, ax plus b, okay? This one here gives us sec squared, okay? Sec squared ax plus b, okay? But then you have to enter inside here, you differentiate this, you also multiply it through, so we shall get a here. So that means when I integrate sec, okay, what do we get? So first of all, I'll take this a away from here, then it comes to this other side. So I will have this one here divided here. You see that? Then when we integrate this with respect to x and we also integrate this other side, so this one is going to cancel with that because the derivative and the integral, they are inverse operations of each other. So that means when I integrate sec squared ax plus b, I'll get 1 over a, then tan of ax plus b. You see that? So when I integrate this one here, it is going to give me 1 over 3 because the derivative of this angle is a 3. So I will divide it, okay? So I'm going to write a third here of tan of 3y. Then this one will be equal to, here when I differentiate, it becomes a negative 4, then I divide through, so it will be e to the power of negative 4x, then out of negative 4, then plus a constant here. Then after that, we can use the initial conditions given here. X is equal to 2, y is 0. So when y is 0, then x is equal to 2. So we shall have 1 over 3, then tan of 0, then is equal to e to the power of, this will be negative 8 over negative 4, then plus c. So meaning when this one crosses this other side, already tan of 0 is 1, okay? I mean tan of 0 is 0. So that means our c is going to be equal to e to the power of negative 8 over 4. Remember, it is a negative here. When it crosses, it becomes a positive. So first of all, when we reach here plus the arbitrary constant of integration here, this is what we call the general solution. Then the particular solution is when we find the value of c. So the particular solution is a third, then tan of 3y, which is equal to negative e to the power of negative 4x, then we divide by the 4, then plus e to the power of negative 8 out of 4. They told us to obtain an expression of y in terms of x, so we make y the subject of the formula. So I can begin by multiplying by 3, okay? So when I multiply all through by 3, we shall get tan of 3y, which is equivalent to 3. I can even factorize this 4 here because it is common here and here, okay? So I can write it like that. Then I put the positive one first, e power negative 8, then minus e to the power of negative 4 of x, okay? And then we take the arctan because we want y, so it will be the arctan of this 3 over 4 multiplying e to the power of negative 8, then minus e to the power of negative 4 of x, okay? Then from there, we divide all through by 3. So meaning y is going to be a third of the arctan of 3 over 4 then e power negative 8 minus e power negative 4 of x, like that. So this is going to be our answer. Question 9, part A. Here we are supposed to express this function here in partial fractions. Now, when we look at the denominator here, we have a quadratic and then the linear. Okay, so we shall have 17x squared. Also, before you begin the partial fractions, always check the degree of the numerator and the degree of the denominator. What do I mean by the degree? It is the highest power of the variable in that given expression. So the highest power here is a 2, so the degree is a 2. The highest power here is going to be when this x squared multiplies with this negative x, so we shall have negative x what? Negative 3x, then cubed. So the power here is a 3. So this is a proper fraction because the degree of the numerator is less than the degree of the denominator. But if the degree of the numerator is greater or equal to the degree of the denominator, you first long divide to make it a proper fraction. So this one, we just proceed right away. Then plus the 16 out of the 2 plus 3x squared, then into 2 minus x. This one is going to be equal to, I can have ax plus b, okay, then divide by, this is 2 plus 3x squared, then plus, I have another constant, this one, because it is linear, then I will just have a constant here, then divide by that 2 minus x. So don't waste time, just multiply this with this, then this with that, and then you equate to this one here. So we have ax plus b multiplying with 2 minus x, and then plus c times the 2 plus 3x squared, then which is equal to the 17x squared minus 7x, then plus 16. Why are we just equating to this one? It is because this one here is the LCM, okay? So this LCM is over the whole of this. So I can write it like this. And also, it is the same LCM, I mean, it is the same denominator that is on this one, what we are given there. So if we have something like that, don't you think that this is the same? So we just cross it out. It is the same. So I just equate when we multiply this and this and that, you equate to the numerator. Okay. Now, you look for the x values that can terminate one of the terms and then you remain with the other. So I can say, let's say x is equal to 2. If x is equal to 2, this whole thing will go because this one will be a 0, 2 minus 2. You get it? Then put a 2 here. 2 squared is 4 times 3, 12. Then plus 2, that will be a 14. So we shall have 14 of c, which is equal to, then put here 2 squared, that is a 4. Okay, 4 times 17, that one gives us 68. Okay, 68 plus the 16, then minus the 7x. So altogether, what does this one give us? So let me use the calculator to simplify the work. 17 into 2 squared minus 7, then 2, then 16. That is 70. So we have here 70. That means when we divide all through by 14, our c is going to be equal to a 5. Then we can get another x value. Since a is multiplied with x here, to terminate it, I will say let x be equal to 0. So when it is 0, here we shall remain with b times the 2 because even this one has gone. So we shall have 2b, then which is equal to, no, not equal to, there is this one here going, then we have 2c. So plus 2c, then is equal to, this one goes, then we have 16. So we shall have a 16 here. So what will be our b? Our b here is going to be equal to 16 minus 2c. That means I get 5 times 2, that will be a 10. So minus 10, then we divide by this 2 here. So what do we get? 6 divided by 2, that is a 3. So meaning b is going to be equal to 3. Okay. Now, since I have exhausted the values of x I can substitute in here such that I terminate the terms, I can now get any other value of x. And the simplest would be 1. So if x is equal to 1, put 1 here. That will be a plus the b, okay? And then this one will be 2 minus 1, that is a 1. So I'll have a, then plus b. Then here I will have 2 plus the 3, that is 5. So we shall have 5c. And then this way we have 17 minus 7. What do we get? 10. Then 10 plus 16, isn't that 26? That is 26. Now substitute for a. A here is going to be equivalent to 26, then subtract 5. C is 5 times 5, which is 25. So minus 25, and you get a 1. Then minus the b, and b is a 3. So 1 minus 3, that one will give us a negative 2. So a is equal to a negative 2. Okay, then I can conclude, and I say that my f of x is going to be equal to a, remember it is ax plus b, so negative 2 of x, or I mean negative 2 of x, then plus the b, then divide by, we had the quadratic down, 2 plus 3x squared, 2 plus 3x squared, and then plus the c, which is 5 over, we have the linear factor, which is 2 minus x. By the way, they can give you a quadratic in the denominator, but that quadratic is factorizable. So we use this ax plus b when the quadratic in the denominator is not factorizable. Okay, so that is that. Now, after them giving us this, when they give you part A to express this in partial fractions, the next part can come from integration or binomial expansion. Now for this part B, it is coming from binomial expansion. So they are saying, hence obtain the expression of f of x in the ascending powers of x up to and including the term in x cubed. So our f of x here, remember, is equal to negative 2x plus 3, which I can write as maybe 3 minus 2x. Then down, we have the non-factorizable quadratic, which is 2 plus 3x squared. Okay, so when I take it up using the rules of indices, the power will be a negative 1. Then we have plus 5, which was the value of c, and then it was over the linear factor, which is 2 minus x. Then when I take it up, it is also power negative 1. So using the binomial expansion, which states that a plus b, then to the power of n, you put the power on the a, then b here starts from a power of 0, and then we have 0 factorial. The power of the b is the factorial we have down there. Then plus, you be like as if you are differentiating that a, so drop the power, then reduce it by 1. When you reduce it by 1, b picks that power, and it is the factorial down here. You keep on doing that, so also drop this one here. We shall have n into n minus 1, then a power, this will be n minus 2, and then b to the power of 2 out of, this will be 2 factorial. Then I can proceed, put this one here. So we shall have n into n minus 1, then n minus 2. Then a will now be the n minus 2, subtract a 1, it will be n minus 3. Then b to the power of 3 out of 3 factorial, like that. You continue. But we are interested in the terms that end up to x power 3. So let's get this one here. 2 plus 3x squared to the power of negative 1. This one is going to be 2 power negative 1. Then bring this 3x squared. You power it with a 0, 0 factorial. Then drop the negative 1. So that is negative 1, then 2 power negative 2, then 3x squared power 1, then out of 1 factorial. Then plus, drop this one here. We shall get negative 1, then times negative 2. Then the 2 here will be to the power of negative 3. And then 3x squared here will be to the power of 2, and then divide by the 2 factorial. Remember, when you add these powers, you see negative 2 plus 1, and also negative 1 plus 0. All of these powers give you the one that is there. Okay, then plus, now drop this one here. We shall have negative 1 times negative 2 times now negative 3. Then the 2 here is going to be to the power of negative 4. And then 3x squared here will be to the power of 3, then out of 3 factorial. Now we simplify this one. This will be 1 over 2. 0 factorial is a 1 because there is one way of arranging an empty set, and also any number to the power of 0. That one is a 1. So we have a half, then minus. This one here is going to be a negative first of all, because we have it here. And then 2 power negative 2 is the same as 1 over 2 squared, which is the same as 1 over 4. But there is a 3 here, so we shall multiply by that 3. So meaning we shall have negative 3 out of 4. So negative 3 out of 4 x squared. Then how about here? This one is a positive 2. We'll cancel with this 2 because 2 factorial is a 2. And then 2 power negative 3, that will be 1 over 8. Okay. Then times, when I square the 3 here, I'll get a 9. So that means I will have 9 over 8. Okay. 9 over 8 of, then this one is going to be x power 4. Okay, x power 4. And I don't need these terms because I'm supposed to end in x power 3. So that means I'm not supposed to have this. I wouldn't even have written this and this one here. Okay, I would have stopped here. Okay, so I'm going to remove this one here and I just remain with this one, then plus whichever is coming forth. Okay, then next we are going to go to 2 minus x, then to the power of negative 1. So this one will be 2 power negative 1, then negative x. Please take this sign along with the x. Okay, or 0, then 0 factorial, then plus 2, negative 1 now times 2, power negative 1 times minus 1, that is negative 2, then negative x here, power 1 over 1 factorial, then plus, drop this power now. We are going to have negative 1 times negative 2, then now the 2 is going to be to the power of negative 3, and then negative x here is going to be to the power of 2, then over 2 factorial. I will stop here because this is going to end in x squared. So meaning here we are going to have 1 over 2, okay? And then this one here, a negative times a negative, that's a positive. And then 2 power negative 2, that is 1 over 4. So we shall have 1 over 4 of x here. Then the next one is going to be this one here is a positive 2, cancels with this one here. But 2 power negative 3 is 1 over 2 cubed, which is 1 over 8. So I'll write here plus 1 over 8. Okay, 1 over 8 of x squared. Oh, here we are going up to x power 3. Okay, so I'm going to add another term here. Excuse me here. I'm going to add another term here. So drop this one here. We are going to have negative 1 times negative 2 times negative 3. Then the 2 is going to be to the power of negative 4. Then here, negative x is going to be to the power of 3 over the 3 factorial. Okay. Now, after this, I'm going to simplify it. Let me try to extend this one a little bit here. Just like that. Now, 3 factorial is the same as 3 times 2 times 1. But all the power of a negative, this is negative 1 times negative 2, that is a positive 2. Then times negative 3, that is a negative 6. Then divide by a 6, so it is going to be a negative. Okay, it is going to be a negative down there. So it is negative 6. Then we have a 6 down here. But here, this one is going to be 1 over 16. There is also this, all the power of a negative is a negative. So this one is going to be negative x what cubed. So this one will go, the negative will cancel with this negative, and then we have 1 over 16, which is a positive. Okay, so I'm going to write here plus 1 over 16 x cubed. So this therefore implies that our f of x is going to be, we have it up here as 3 minus 2x. Then this expansion here is what we got here. So I'm going to put this one here like this, a half, then minus 3 over 4. Remember, we ignored the other power that was coming forth, which was x power 4. Okay, then this is x power 6, so we don't need them. Now, the next one here is plus 5, then times what we have gotten here, okay? And this one is also continuing. So we have a half, then plus 1 over 4 of x, then plus 1 over 8 of x squared. These are what we call infinite series, okay? They don't end. So that's why they tell you to end somewhere. We don't need all the terms. So multiply everything in here. We shall have, let me begin with the constants, okay? So this is a constant, it will multiply with the constant. So I will have 3 over 2 here, okay? There is 5 times 1 over 2. That one will give me 5 over 2. So this is my constant part. Then plus, let's pick out the terms that are going to end in x. So we have this one here, negative 2x times a half, okay? So I'm going to write negative 2x times a half. This one will give us a negative 1, right? So I'm going to write negative 1, okay? Negative 1. I'm leaving out the x. I'm going to put it later, okay? Then what else ends in x? It is 5 times a quarter of x. So we shall have 5 over 4, okay? There is nothing else, so x here. And then the terms that are going to end in x squared, this 3 will multiply with this one here, which will give us negative 9, okay? Negative 9 over 4, okay? This one, when I multiply with this one, it will give me cubed, so I will come back for it. Now, 5 times this one here, it will give us 5 over 8. So plus 5 over 8. This one is for x squared. And then for x cubed, it is this negative 2 times this one here, okay? So we shall have negative 2 times negative 3 out of 4. Of course, this one cancels this one here. So we shall get 3 over 2, okay? So I'll write 3 over 2. And then we also have 5 here times this one here, 5 over 16. So plus 5 over 16 of x cubed, okay? So what do we get here? 3 plus 5, you'll get 8. Then divide by 2, that one gives us a 4, okay? Then 4 times negative 1, you'll get negative 4. Then plus 5, that one will give us a 1. So we shall have a quarter of x. Then here, what I will have is to multiply this by 2 and this by 2 because this is 8 and this is 8, okay? The denominator to be the same. So in that case, I'll have negative 18, then plus 5. That will be negative 13. Yes, negative 13. So that means I will write negative 13 here over 8 as the coefficient of x squared. And then here, I will multiply this by 8 to get the same denominator as this one here. Also here times 8. So this will be 24 plus 5. 24 plus 5, that one gives us 29. So that means the coefficient of x cubed is going to be 29 out of the 16 x cubed. There are other terms that come forth, but this is what we are interested in up to the terms ending in x cubed. So that is that. Then part C, state the values of x for which the expansion in B is valid. Okay, give your answer in the exact form. Now, we are going to use, we are going to base on this one. In the list of formulae, they give you something like this. If you have an expansion for 1 plus x, then to the power of n, the validity here, the validity is the modulus of x less than 1, or you have negative 1 less than x less than 1. You see? Now, what we are going to also have here, it is going to be the same thing. So we are going to make sure that we create a 1 here. So how do we create the 1 there? I will come here to my expansions. I have this one here and this one here. Okay? So I will factorize out that first part such that I get a 1. Now for this expansion, 2 plus 3x squared, then to the power of negative 1, I'm going to factorize out the 2 so that I create a 1 here. That means this one is going to be 3x squared over 2. okay? And then this whole thing is going to be power negative 1. So meaning we shall have 2 power negative 1, then 1 plus 3x squared over 2, like this, which is going to be power negative 1. Then from there, I have to find my x, okay, the expression for x, because here we are having x, okay? So what does this one come from? We are going to have something like this here. This one is the same thing. I can have 1 plus, then this can be root of 3, then x over root of 2 squared, okay? Then I need this part here for x. So I'll put it, its validity here is going to be, it is the one that I'm going to put in this modulus here. So I'm going to have root of 3, then x over root of 2 in the modulus. Then this one is less than 1. So then using the properties of modulus, this coefficient of x here is going to go out, okay? So I will have root of 3 over root of 2, then the modulus of x, which is less than what? 1. So meaning I'm going to multiply all through by root of 2 over root of 3 to take it away from here. So we shall have the modulus of x here less than, then root of 2 this way, over root of 3, okay? I multiplied through by root of 2 over root of 3 to cancel it from this way, and then it also comes this other side, okay? So that is what we are having there, which is the same as saying negative root of 2 over root of 3 less than x less than positive root of 2 over root of what? 3. Now let's also look at this 2 minus x. I also need to create a 1 here, so pull out a 2, then 1 minus x over 2. Then this one is power negative 1, so I will have a power negative 1 and also here. So meaning I will have my validity, okay? What will be the validity of this one? The validity is going to be get that negative x over 2, put it in a modulus, then less than 1. So this one is a negative. In the modulus signs, it comes out as a positive. So I will have a half here, then the modulus of x, and then less than 1 here. So if I multiply all through by 2, then that simply implies that we shall have the modulus of x, then less than 2. So meaning we shall have negative 2 less than x less than 2. Okay, so I have these 2 where I'm supposed to pick the intersection. Okay, so by trying to sketch something here on a number line, I have maybe 0, this one is 1, this one is 2, then this way we have negative 1, then negative 2. So we have this negative 2 and the 2, they are not included. So I'm going to put them in. I'm going to use that circle which is not shaded. Okay, you remember inequalities in O level. Then I also come to this one here. What is the value of root 2 over root of 3? This is root 2, then we divide by root of 3. We get root 6 over 3, but that is 0.816. So 0.8, it is around here, and then also here, okay? It's beyond the half. So I'm going to put it somewhere here. Now I have this and this one here. Now, when I try to connect here, this is the common region for both of them. So that means the whole validity, the overall validity is actually going to be this negative root 2 over root of 3, then less than x, less than root of 2 over root of 3. And that is going to be our answer. Question 10. The diagram shows the curve y is equal to x cos 2x for x greater than or equal to 0. Find the equation of the tangent to the curve at the point where x is equal to pi over 2. Now, we need, in order for us to find the equation of the tangent or the equation of any straight line, you need to find the gradient and also at least one point through which through which the line passes. Okay, so for x is equal to pi over 2, what will be the y coordinate here? So y is equal to pi over 2, then the cosine of this is 2 times pi over 2. Now this one will be 180. Cos of 180 is a -1, so we shall have -1 times pi over 2, which is the same as negative pi over 2. So meaning the coordinate through which the line will pass is pi over 2 and negative pi over 2. Now, to find the gradient, remember for any curve, okay, the gradient is that, the tangent is that line which meets the curve at only that one point, okay? And then there is, of course, this other line which is perpendicular to the tangent. That is what we call the normal, okay? So for this tangent, and this is the curve here, then this one becomes the normal. We have the gradient between any 2 points on the tangent is always constant. So if I have these 2 points, the gradient here is the same as the gradient between these 2 points, is the same as the gradient between this point here and this other one here, like that. It is constant. But the gradient between any 2 points on a curve is always different, okay? So that means at the point of intersection, the gradient and the tangent will always have the same gradient. So, and gradient of the curve is got by differentiation. Differentiation is the process of finding the gradient of a curve. So we need to differentiate, and after differentiating, the gradient function we are getting from there is the one that is going to help us find the gradient of the tangent. So since this one is a product of two functions, we are going to use the product rule, okay? So our dy dx is going to be, we make this one constant, then we differentiate the cosine of 2 of x. Then from there, we can keep cosine of 2 of x constant, and then we differentiate the x, okay? So what do we get here? When we differentiate cos, we get a negative sign, okay? We get a negative sign. This one is of 2x, but then we shall enter here and we differentiate that to x, then we get a 2, then we multiply through. That is chain rule. So we shall multiply through by -2, okay? And then here, of course, when you differentiate x, you will get a 1. So meaning here we are having 2 of x, a negative, then sine of 2x, then plus the cosine of 2x. Now we can substitute this x coordinate. So if x is equal to pi over 2, then our dy dx is going to be equal to -2 times pi over 2, which will remain as negative pi, then sine of 2 times pi over 2. This will be sine of 180, which is 0. So the whole thing here disappears. Then cosine of 2 times pi over 2, cosine of 180 is a -1. So that means our answer here is going to be equal to -1, okay? Now using y minus y1, which is equal to m into x minus x1, we are having this coordinate pi over 2 and then -pi over 2, where this one is going to be our x1 and then y1. So we just substitute here y minus, then minus pi over 2, and this one becomes a plus, right? Then this side, the m is the gradient, -1, then into x minus, x1 is pi over 2. So meaning when we open up the brackets, first of all, this is y plus pi over 2. Open the brackets here, you will have -x, then plus pi over 2. So this pi over 2 and this one, they will disappear. So meaning y is equal to -x is the equation of the tangent. Part B, find the exact area of the shaded region shown in the diagram, bounded by the curve and the x-axis. So when we check again the area we are having, they said bounded by the curve and the x-axis. So this is the one here, the shaded region. Now we need to find the limits, okay, from 0 here, but now to what? Which point is here? So we need to find it. And we know that on x-axis, y is equal to 0. So I will come here and I say that on x-axis, y is equal to 0. So what is our y? It is x cos 2x, which is equal to 0. Automatically, when I equate this one to 0, it will give me a 0. So that is the starting point. Then cosine of 2x is going to be equal to 0. That means we shall have 2x, which is going to be equal to the arc cos of 0. And then this one actually gives us 90, which is pi over 2. And there is also 3 pi over 2. That is the 270. So meaning the x values that I can pick from here can be pi over 4 and then the 3 pi over 4. And of course, I will take this one here, okay? Because when you check here again, it is a smaller one here, okay? We have 0, then this should be pi over 4. Then the next time it cuts the x-axis, that will be the 3 pi over 4, okay? And then many more. So we are taking those smaller values there. Now, you know that when we are finding the area, we integrate. So the shaded area for this case is going to be the integral from 0 to pi over 4. And then we are integrating. The function is x, then cos of 2x. Now you realize that this is a product of two functions. And when we are integrating a product of two different functions, we use integration by parts. And for integration by parts, I've always shared that you use this acronym ILET. It helps you to get to know which one am I supposed to differentiate, which one am I supposed to integrate. Because in integration by parts, one function has to be differentiated and then the other function integrated. So I represents inverse trigonometric functions, L represents logarithmic functions, A represents algebraic, and we can see algebraic here. So we shall take this one, algebraic function, and then this one is trigonometric. So these are the two that I'm using, trigonometric. Then the other one is exponential, okay? So I'm taking only these two. So the one which comes first is the one you're going to differentiate. So therefore, I'm going to have my u, which is going to be equal to that x, okay? The one you equate to u is the one you're going to differentiate. So what is du dx? This one is going to give us 1. And then what is dv dx? dv dx is going to be that cosine of 2x. So meaning v is going to be the integral of this cos 2x. Then when you differentiate, when you integrate cosine, you get a positive sign. But then you divide by the derivative of the angle, which is a 2 here, okay? So from, integration by parts, even this one is given in the list of family. So from the integral of u, then dv dx, we are integrating this with respect to x. We are getting uv minus the integral of v, then du dx with respect to x. So we are going to have here our shaded area. Shaded area is going to be equal to, what is the u? U is x, v is this one here. So I will write x, then sine 2x divided by 2 minus v is sine 2x, then divide by 2 times du dx, we got it as 1 here. So times the 1, then with respect to x, okay? Then from here, I can even put the limits. This is pi over 4 and then 0. Then from here, I can first simplify this x sine 2x. We divide by 2 minus, I'm going to put a half here. When you integrate sine, you get negative cosine. So I'll get negative cosine of 2x, but remember we divide by the derivative of that angle because it comes from the derivative of that sine of 2x. And then you know that we use the chain rule, we multiply all through. So to undo the multiplication, then we divide. So that's why we divide by 2 here, okay? And then from there, we put our limits, pi over 4 and 0. So by substituting, we are going to get this is pi over 4, then sine of 2 pi over 4. Of course, that will be 2 times 45, that's a 90. Sine of 90 is a 1. Then this will be a plus. Remember, this is a multiplication here. Plus, this is a quarter, because this times that is a 4. And then the cosine of 2 times pi over 4. Cos of 90 is a 0, okay? Then we subtract. When we put 0, of course, automatically everything there goes. Then plus a quarter, and then cosine of 0. Cosine of 0 is 1. So here, this one is 1. Then pi over 4, then divide by 2. That one will give us pi over 8. Then this one is 0. So we shall have a 0 here. I won't write it. Then this one is going to give us a 1, so minus a quarter. Just like that. So I can leave my answer there. They said find the exact area. I can leave it there, or I can multiply this one by 2, then by 2, so that I write 1 over 8 altogether as the LCM. 8 as the LCM. So this will be pi minus 2 over 8. Okay. So I can write pi minus 2 out of 8 as my final answer. So that is that. Question 11. The line L has the equation, this one here. The points A and B have position vectors, these ones. Find a unit vector in the direction of L. So the unit vector in the direction of L, we are going to get the directional vector of L. So let me write a statement here. Unit vector in the direction of L is actually represented by D, because the directional vector of L is this D. Let me just write it as DL, okay? Then we put this cap here. It represents the unit vector. So you get that vector, then you divide it by its modulus, okay? You divide it by its modulus. So what is the modulus of the directional vector? So first of all, the directional vector of L is this one you see inside here. So we shall have -1, then 1, then 2. Okay? Then from there, the modulus of this one is going to be the square root of -1 squared, then plus 1 squared, then plus 2 squared. This is 4 plus 1 plus 1. Isn't that a 6? So we shall have root of 6. So that means the direction vector, the unit vector in the direction of L is going to be equal to, we have 1 over root of 6, then times -1, 1, 2. Or you can write it as -1 over root of 6i, then plus 1 over root of 6j, then plus 1 over root of 6. Here there is actually 2, and then you write k. So you can write it like this or like this, okay? So a unit vector, of course, it is going to give its modulus as a 1. The length is a 1. Let's check it out. I can have this one here squared. So -1 over root of 6 here squared, then plus 1 over root of 6 squared, then plus 2 over root of 6 squared. Now here I will have a 1 up, a 1, and also a 4. Down here, when I square the square root of 6, it is going to give us a 6. So all of it together is 6. So do you see that up we are having a 6 over 6? So you get a 1. So that is that. A unit vector has its length as a 1. Then next they are saying the line M passes through the points A and B. And then they are saying that find a vector for M. Okay, passes through the points A and B. Let's say I have my A here, and then my B is there. But then there is another point on this line whose coordinates are X, Y, and Z that I don't know. It's like when you are starting from your home, this is the origin, okay? And then you move like this, you go to where the road starts from. You are coming from your home. So the road, you join the road from here, okay? Then there is a place you pass through. Maybe you have your auntie, maybe you have what, but you know that place, okay? And you know the distance that is here. But then as you go wherever you are going, the distance keeps on increasing. So there is a point there are many points you keep on passing, okay, whose length is going to be a certain scalar you're going to get, and you multiply into AB. So in other words, you are going to get OR. You're supposed to get this O to R. So that OR is going to be equal to OA, then plus AR. But since you don't know AR here is parallel to AB. And parallel vectors are said to be so if they are scalar multiples of each other. That means OR here is going to be equal to OA, then plus a scalar. I can use mu since the other line has gotten the lambda. So I can put lambda, then times the vector, which I know that is parallel to this one here. So this is that. So we need to find AB. This becomes the directional vector, okay? So what is our AB? AB is going to be OB minus OA. Why am I saying the last minus the first? It's because if I'm going from A to B, I will say A to O, then plus O to B. But A to O is the negative of OA. You see that? Look at this arrow and look at this one here. They are moving in opposites. So we shall have negative of OA, then plus the positive of OB, which is the same as saying OB minus OA. You see that? So that is what we are supposed to have there. So what is our OB? Our OB is given as 3, negative 1, 1. 3, negative 1, 1. And then our OA is given as negative 2, 2, negative 1. Negative 2, 2, negative 1. So when I subtract these ones, of course, 3 minus minus 2, that will give us a 5. The negative 1 minus 2, that is negative 3. And then 1 minus minus 1, that will give us a positive 2. So meaning the equation of the line M, is going to be R, because O to R is R, okay? So R is equal to OA, which OA is this one here. So I'll write negative 2, 2, negative 1, then plus mu, and then our AB is this one that we have gotten. So it is 5, negative 3, 2. Alternatively, you can write your R as negative 2i, then plus 2j, then minus k, then plus the lambda, and then inside here you have 5i minus 3j plus the 2k, okay? You can also have it that way. So that is that. Then the last part of this paper, they are saying determine whether lines L and M are parallel, intersect, or askew. If lines are parallel, that means the direction of vectors must be scalar multiples of each other, okay? So let's find out the directional vector of L. First of all, here, the directional vector of L is given as, it is here, negative 1, 1, 2. So the directional vector of L is negative 1, 1, 2. And then the directional vector of M is the AB. We have seen it as 5, negative 3, and then 2. Okay, so these ones, this one cannot be expressed in terms of this one. So that means these are not parallel lines. Okay, not parallel because the directional vectors are not scalar multiples of each other. Okay, that is one. Do they intersect? I need to find out. So what is R1? I can make this one R1 for L. I will write the parametric equations. Okay, so I have 1, then minus lambda, then I have -2, then plus lambda, and then I have -3 plus 2k. Okay, so this is what I'm going to have here. I'll write them parametrically: 1 minus lambda, -2 plus lambda, and then -3 plus 2 lambda. And then R2, it will be the one for L, or the one that is through A and B. And we have already gotten it here. We have -2, then plus 5 mu, 2 minus 3 mu, then -1 plus 2 mu. Okay, so I will write it here as -2 plus 5 mu, then 2 minus 3 mu, and then -1 plus 2 mu. So do they intersect? Then I will say for intersection, the x coordinate has to be equal to the x coordinates are equal, the y coordinates are equal, the z coordinates are equal, because they have that point of intersection, right? So as simple as that. For intersection, I'll have 1 minus lambda is equal to -2 plus 5 mu. And then -2 plus lambda has to be equal to 2 minus 3 mu. And also this one has to be equal to that. Now I'm going to use these two equations. I solve them simultaneously. I get the value of lambda and the value of mu. Then after getting those two values, I come here and I substitute back. So when I substitute in the third one, is it satisfied? If it is satisfied, then that means that the equations, the lines intersect. If it is not satisfied, that means the lines do not intersect, and therefore they will be skew. Okay, now let's check this one here. I will just add these two such that I eliminate the lambda, because if this is minus and the other one is plus, automatically it has to disappear. So 1 plus -2, we shall get a -1, and then this way -2 plus a 2, this one disappears, and then 5 plus a -3, you will get a -2. So we shall, a +2, we shall get 2 mu. So meaning mu is going to be equal to -1/2. You see that? Then from there, I can substitute back for lambda. So -2 plus lambda is equal to 2 minus 3 times -1/2. So what will be lambda? Lambda will be equal to 2 here, then plus 3/2. Then I take this one this side, it will be a positive. So +2. Okay, so 4, because this plus this is a 4. 4 times 2 will be 8. Then plus the 3 here, it will give us 11. So lambda is going to be equal to 11/2. Now testing with the third equation. Okay, testing with the third equation. So what is that third equation? The third equation is -3 plus 2 lambda. It is here. Then we equate to -1 plus 2 mu. We get the same value on the left as on the right. So we get -3 plus 2 times 11/2. Then is it equal to, we are asking ourselves a question. So -1 plus 2, then times -1/2. So this one will cancel with this, and then we get -3 plus 11. That one will give us 8, right? So this one will give us 8 this side. And then this way, this one cancels with this. So we shall get -1 minus 1. That one will give us -2. So these two are not equal. So since this one has failed, then the two lines do not intersect. The lines, therefore, the lines L and M do not intersect. They are not parallel, so they are therefore skew. The lines L and M do not intersect and are therefore skew. So that is it. So this has been it for this last part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.